Alright, here we have question 6 of the November 2019 paper 1. And this question is all about financial mathematics. Right, so we've got question 6, 6.1, and then we've got 6.2 here. So let's get right into it. Question 6.1, we are told two friends, Kuda and Tabo, each wants to invest 5,000 Rand for 4 years. Kuda invests his money in an account that pays simple interest at 8.3% per annum, and at the end of the 4 years, he will receive a bonus of exactly 4% of the accumulated amount. Tabo invests his money in an account that pays interest at 8.1% per annum, compounded monthly. Whose investment will yield a better return at the end of the 4 years? Justify your answer with appropriate calculations. Alright, so let's do calculation for each and see who gets the most money. Let's start with Kuda. Okay, so Kuda. So he does simple interest. So let's write down a simple interest formula to start with. So our simple interest formula is A equals P, the principal amount, A is the amortized value or the end amount, P is the principal or the start amount, times 1 plus our interest times the number of years. Okay, and we have the values, but before we do that, let's just say, because there's a little extra part here, you will receive, after the 4 years, you will receive a bonus of 4% of the accumulated amount. Okay, so this amount will accumulate, it'll give us that, and then we have to add to that. We have to add to that 4%. So 4% is 4 over 100, and what has he accumulated? Well, this part, so we can just rewrite that formula. So P 1 plus I times the number of years. Okay, so that is how we'd write it in one line, and I think that's fine. Let's work that out. So let's first write down what the values are that we know. So we know that P is the 5,000 that it will invest. I, the interest rate, is 8.3%, 8.3%, and that's per annum. And that is how many years? N will be 4 years. Okay, now let's plug that in and solve our equation. Okay, so we'll have A equals P times 1 plus I, so the interest is 8.3%, so that is the same as 0.083 times the number of years, which is 4. But then we add to that 4% of the total, which is just a rewriting of this part. 5,000, 1 plus 0.083 times 4. And there we have it. Now let's just calculate that. So you can just type this whole thing on your calculator, and that's what I'm going to do. And that'll give us a final answer. Oh, let's do this part first. So this part give us our first part of the answer, which is 6660 plus, and this part will give us 266.4, and we add those together and we get 6926.4. And remember to put your unit signs whenever we write our final answer. So 6926.4. So that is Kuda. Now let's look at Tabo. So we'll do him in green. Tabo in green. So there he is. Now let's read his information again. So here we go. So from there. So Tabo invests his money in an account that pays interest at 8.1% per annum, compounded monthly. It says compound interest of 8.1%. Okay, so our compound interest formula, first of all, is A equals P 1 plus I, and that's over M. So this is the number of compounding periods per year, and then so that times the number of years. So this will be our total compounding periods. Now it's fine if you just write an N here. You don't have to write M times N. I just want to do that to keep the compounding periods and the number of years separate, so we can have more information about the exactness of what's going on. Okay, so what we know here, P again is 5,000, that's the same amount that he invests. I, the interest rate, that's 8.1%. The number of times it gets compounded per year is 12 because it's monthly. And N, our number of years, is still 4. Okay, let's do the calculation. So here we go. A equals P, which is 5,000, 1 plus 0.081 over 12. And that's all raised to the power 12 times 4. Right? 12 times 4. Okay. Then let's work that out. So that gives us A equals, if we just type that on a calculator, we should get 6905.71. And again, remember your unit signs. So that's Tabo's value. Now the question asked, whose investment will yield a better return at the end of the 4 years? Justify our answer. So we've done both calculations, and we see that is what Kuda got, 6926.4, and Tabo got 6905.7. So who wins in essence? That would be our final answer, would be Kuda. Kuda has more money. He gets more value after the 4 years. And we've proven that with our calculations. Right, next question. Now this question 6.2, this is where the new work in essence comes in. This is the future value and present value calculations. So let's just write down those formulas before we start. So present value is equal to x, and then we've got 1 minus 1 plus I, and I'm going to write I over m again because of the compounding periods, to the power negative n. So negative n, yeah, I'm just going to use an n, not m times n in this case, all over I over m. So that's present value. Future value looks fairly similar, and that will be x times, and then we have 1 plus I, and again I'm going to write I over m, to the power n minus 1, and all of that again over I divided by m. So there's our two big new equations for grade 12 that we need to know. Okay, let's see what the questions ask. So it says 9 years ago, a bank granted Mandy a home loan of 525,000 Rand. This loan was to be repaid over 20 years at an interest rate of 10% per annum, compounded monthly. Mandy's monthly repayments commenced exactly 1 month after the loan was granted. Now this part, exactly 1 month after the loan was granted, that means we don't have to adjust n in any way. That's the normal thing. If it says 1 month after, that means we just use the formula as is. If it says started immediately, then, which is a common thing in these questions, then we have to add an extra 1 to the n value because it's 1 month extra or 1 period extra. Okay, 6.2.1 says Mandy decided to make monthly repayments of 6,000 instead of the required 5,066.36. How many payments will she make to settle the loan? Okay, so what we know here is now we're going to use the present value formula, and the present value formula is always used when anything is being repaid. So in essence, some amount has already happened in inverted commas, like a loan. You've already received the money, now you have to repay. Another option would be if, let's say, you've won the lotto, and so in essence you've already won all that money, but they're paying you out in installments. So that's present value. Future value is when you're trying to build up to something, so that amount has not already happened in a sense, you're just trying to get there, so you're building up to some amount. Okay, but generally if you read something about loan, you know you're going to use present value. Okay, so let's just plug these in. So 6.2.1, the 6.2.1. Okay, Mandy decided to make monthly payments of 6,000 instead of the required 5,066. Okay, so present value, so that is the loan amount. So that'll be 525,000 equals X is our monthly repayments. So we're going to say that's going to be 6,000 instead of the required 5,066.36. Okay, so we're going to use that. 1 minus, and then 1 plus, the interest rate is 10%, so that's 0.1. And that's compounded monthly, so it's 12 times per year. To the power of negative n, we don't know how many payment periods. That's what we want to figure out in this question. That's all over I over m again, so 0.1 over 12. Okay, now we need to solve for n. So first thing I'm going to do is I'm going to multiply both sides by 0.1 over 12. So 525,000 times that will give us 4375. 4375 equals 6,000. 1 minus 1 plus 0.1 over 12, all raised to the negative n. Then we can go further, divide by 6,000, so 4375 over 6,000. If we simplify that, we get 35 over 48 equals 1 minus 1 plus 0.1 over 12, all raised to the negative n. Then we can take the 1 across, so 35 over 48 minus 1 gives us negative 13 over 48. And that equals negative 1 plus 0.1 over 12 to the negative n. And now the negatives can cancel out. I'm just going to use red to cancel those out. You can multiply both sides by negative 1 or divide by negative 1. What matters is the negatives are now gone. Okay, we have to solve for something that is in an exponent. So the best way to do that is with logarithms. So we'll just take log of both sides. Log of 13 over 48 equals log of 1 plus 0.1 over 12, that's an ugly one, to the negative n. And the reason why we do that is because logs can transform exponentiation into multiplication, which is very neat. So the exponent can move to the front, negative n log 1 plus 0.1 over 12. And then finally we can divide both sides by this log part. Let's write that down. Let's divide by log 1 plus 0.1 over 12. And divide this side by log of 0.1, by 1 plus 0.1 over 12. 1 plus 0.1 over 12. So that cancels out. And then we're left with this whole thing equals negative n. But I'm just going to write all of that down again. So log of 13 over 48 over log of 1 plus 0.1 over 12. That equals negative n. So this whole thing we can just type on our calculator, which will give us a negative 157.4 something something equals negative n. So the negatives again can cancel out. For consistency, let's just cancel them out in red again. And that means, so it's going to be 157 point something payments of 6,000. So it's going to be 157 payments of 6,000 plus another payment of less than 6,000. So the total number of payments is going to be 158. There we go. That was quite a mouthful. Big long calculation with this present value question. Now let's look at 6.2.2. So after making monthly repayments of 6,000 for 9 years, Mandy required money to fund her daughter's university fees. She approached the bank for another loan, but instead, the bank advised Mandy that the extra amount repaid every month could be regarded as an investment, and that she could withdraw this full amount to fund her daughter's studies. Calculate the maximum amount that Mandy may withdraw from the loan account. Okay, so like we said, so that this will be a future value thing, because there's some amount extra that she's paid in every month, and she gains interest on that as well. So that'll be a future value thing because there's monthly payments. So we need to find out what this future value is after all the monthly payments, but this monthly payments that she's made for 9 years. And that'll be the amount that she can withdraw. But the X, the monthly payments, will just be the difference between 6,000 and the 5,066 because that's what she paid in extra. Okay, so let's go all the way down. I'm going to start that on a new page. Okay, so 6.2.2, 6.2.2. So let's just write down our future value formula again, because we'll be using that. So future value equals monthly repayments, which is X, and that's 1 plus I over M to the power N minus 1 all over I over M. Okay, now let's write down what we have. We don't know what F is, that's what we want to find out. We know X is, that's the difference between what she paid and what she needed to pay. 66, sorry. I'm going to write that over again. 5,066.36. Okay, so what does that give us? That gives us 933.64. So that's what X equals. We know our interest rate, that's 10%. The compounding period is monthly, so that gives us M of 12. And N is the total number of compounding periods, so we know that's 9 years. So 9 years times 12 times per year gives us 108 months, 108 compounding periods. Okay, so all the values we need are right here, and now we can just plug and play. So let's do that. Let's plug and play. Okay, F equals X, which is 933.64, times 1 plus I, the interest rate is 10%, which is 0.1, over 12 monthly to the power N. We said that's 108 compounding periods, minus 1. Oh, sorry, let's do that. There we go. Sorry for the ugliness of the writing. And that's all divided by 0.1 over 12. Okay, that's great. Now we can just plug that whole thing in our calculator. Easy as that. That's the bonus about modern day mathematics, right? We can do some of these complicated things like exponentiation on calculators. So if we type all of that in, we get an answer of 162,503.51. So that is, again, rands. I might have forgotten that in the previous question. We have to put our units. So that is the amount that she could take out as a loan to fund her daughter's studies. Or not as a loan, actually, just as an investment that she's made. And here, that was fine. Okay, so that is it for financial mathematics. Please let me know in the comments if you find anything interesting about this, or if you have a different method of solving these, or if you have any questions about why we use some of the formulas. Thank you.